and studying how to solve linear equations. And here's our first topic. It is in section 1.1 of your book, and it's entitled Solving Simple Equations. So we'll start off with some basic foundational skills. And the big idea for this section is that we need to use inverse operations, which are operations that undo each other. So if I'm adding a number and I want to undo that addition, how would I do that? Well, you would subtract it back off, and then vice versa. And multiplication and division are considered inverse operations of each other. All right, so that's one idea we need to use in solving. And then the second idea is that of balance. When you make a change on one side of an equal sign, you must do that same exact change on the other side to preserve the solution or the value that would be obtained in the solving process. All right, so keeping the balance preserves the solution at each step of the way. If you don't do the balance, then the solution you end up with might not be the solution of the original equation. So balancing is vital. All right, so we're going to do some examples now. All right, so in our first set of examples, we're going to be solving, here's 3 problems, and I'm going to take a look when I tackle an equation. First thing I do is write it down, and then I observe what's going on with the equation. So these are very simple equations. They will get more complex, so it's important to develop good habits. So I'm going to look at this equation. Here's my variable x, and what am I doing to it? I am subtracting 7. Just one operation there. So what I want to do is undo that, do the inverse of that, subtraction, so that I can get x by itself. That's our ultimate goal, is to get x on the left side of the equal sign, the number on the right, and that will be our solution. All right, so subtracting 7. So how do we undo that? We do addition. All right. Now notice I didn't look at the right side, which doesn't have a variable. I'm just ignoring that. That's just going to play a part in the simplifying process, but what I care about is what's on the side of the variable. All right, so I'm going to undo minus 7 by adding 7 on the left side, and then I go to the right side and I do the same exact thing. That's the idea of balance. Okay, and then we're going to simplify. So on this left side, opposites always add to 0. So I'm going to cross it out and write 0. So I'm really adding x and 0 now on this side, and that is just when you add 0, it doesn't change a value, so that's going to remain as just x. I bring that down. All right, now balancing, I'm going to bring down this equal sign represents the balancing point, so you want to keep that lined up as you're doing your solving process. So my equal sign will go right underneath. And then on the right side of the equal sign, I have to combine these, which gives me a value of 1. Negative 6 plus 7 is positive 1. Now we're down at this last line where we have the variable by itself, a number on the right side, and that's as simplified as it can get, so that constitutes our solution. And so as a quick check, in simple problems, a check step can be done with mental math. But we do want to develop good habits, so you want to at least do this mentally, is a substitution of that solution back in to make sure it works. So if I put this 1 here where the x is, so that's 1 minus 7, and I do the math on that, I get negative 6. And so that's my check step. Excuse me. All right? All right, so let's move through these a little bit faster. Just want to use the strategies and apply them each time. All right, so this is where my variable is, w plus 2. I'm adding 2 to it, so I'm going to undo the addition using subtraction. So I'm going to subtract 2. And then I have to balance. When I change one side, I have to change the other side exactly the same way. So again, I'm going to subtract 2. All right, and then simplify each side. Opposites add up to 0, so I cross that out, write 0. So it's w added to 0, which is just w. And then I bring down the equal sign. Notice how it lines up. And then negative 5.6 and a negative 2 combined to give me negative 7.6. And that's my answer. All right, another good habit to develop is, especially to help your teacher know where your answer is to box it. So let's make sure we're doing that. Box or circle, sometimes underline. Whoops, kind of went through my answer. That wasn't a good circle. All right, next problem. I've put this in here because it seems to have a couple of symbols here. This says h plus 2 pi. All right, so you do want to remember that this symbol, sometimes they write it with a wavy line on top, sometimes you'll see it with a straight bar, and whatever is most convenient for you, but that's the symbol of pi. And it has the value, it's a numerical value. This is not a variable, it is a number, an irrational number, because it's a decimal value that where the decimal portion of it continues infinitely long. There's no pattern to it whatsoever. So, and we usually approximate it. So here's the approximation symbol, is an equal bar, which is with where the lines are wavy. And so pi is approximately, we usually go to the hundredths place, 3.14. All right, so I hope that's familiar. So this is really just a number. It's 2 times the number pi. And on the right side, we have 7 times the number pi. So these are just numbers, not variables. The variable is h, and we want to isolate that. So I look at what's being done to h. We're adding 2 pi, so do the opposite and subtract 2 pi. Both sides. And so on the left side, we add up to 0. H plus 0 is h. And then 7 pi minus 2 pi leaves us 5 pi. And that is my solution. So if I do a little mental math and substitute that value back in here, I get 5 pi plus 2 pi, that's 7 pi. Check. All right. All right, so let's do a little practice now with inverse operations of multiplication and division. And so take a look at your equation. The variable is on the left side this time. And this is division. The fraction bar represents division of two numbers, and the top number is being divided by the bottom. So y divided by 4. All right, I want to undo that division. So let me rewrite this problem. And I'll show the undoing on the next line. All right, so undoing division with multiplication. So I'm going to multiply this number, so we can do it with parentheses or with a dot. I'm going to multiply it by the number 4. And then I do the same thing on the other side of the equal sign. Multiply by 4, balance. All right, now remember that the number 4 is the same thing as 4 over 1. Any whole number is made into a fraction by putting it over the number 1. So the 4 and the 4 in the numerator and the 4 in the denominator divide each other. 4 divided by 4. So we get 1s. All right, and that leaves us with y over 1, which simplifies to just y. Bring down the equal sign. And now we're doing negative 7 times 4, which is negative 28. And so this is our solution. And if I substitute that back in, negative 28 divided by 4 is negative 7. Check. All right, repeat. In this exercise, x is on the right side, so you really have to pay attention to where is that variable. So I want to isolate x. I want to get rid of pi. And these are multiplying each other. When you see a number and a variable together, that's side by side, that means multiplication. So we need to undo that with division. So I'm going to divide by pi on both sides. Let me show that in color here, the change. So divide by pi, and I divide the left side by pi. All right, so pi divided by itself is the number 1. So I reduce that down. And then on the left side, pi divided by pi is still 1. So I have 3 times 1 over 1, which is 3, equals 1 times x, which is x. So there's my solution. It is traditional to write the variable on the left, so I will switch sides. X equals 3. Substitute it back in to do a check. and I would get 3 pi equals pi times 3, and that makes sense. Okay, one more. All right, so we have this fraction multiplying the variable w equals -2. So what does w have to be to make this statement true? So let's go through the solving process. Especially when I see multiplication division, I often rewrite the problem and do my work on the next line. All right, so I'll begin with rewriting. All right, I want to undo this. I want to get rid of this fraction. So I want this example specifically because it's been a while since you may have worked with fractions. It's good to review. How would I undo this? Well, notice over here, I got rid of the 4 when the 4 was in the denominator. So these cancel each other out. So I'd like to get rid of this 4 in the denominator. That means I need to multiply by a 4 in the numerator. And then vice versa, I need to get rid of this 3. I'd like it to cancel with a 3 in the denominator. So what I want to do is multiply by the reciprocal, 4 over 3, and so that I can reduce these numbers. There's also this negative value that I need to get rid of as well. So I need to my number to have a negative on it. So let me wrap this on the left side, and I'm going to multiply by the reciprocal of the fraction, which would be -4 over 3. And then I repeat that on the right side, multiply by -4 over 3. Okay, and so what happens is the negative times a negative is a positive on the left side, so those become positive. And then 4 divided by 4, right? So we reduce those down, become 1s. 3 divided by 3, that becomes 1. So this is 1 on the numerator, 1 in the numerator, 1 times 1, 1 times 1. This is number 1 times w, which is w. And then again, there's that negative times a negative, so we're going to have a positive answer. And so I'll just change those to plus signs. And this is really 2 divided by 1. Remember, it's a whole number. You just put it over 1. So I multiply the numerators together. 2 times 4 is 8. And then 1 times 3 in the denominator, so 8/3. It is satisfactory to leave a fraction answer in improper form. That is fine. You can also convert it to mixed form, which means that you do a division and then find out the remainder. So if I divide 8 by 3, I know that 3 goes into 8 twice. 2 times 3 is 6. So that's my whole number part. So I can rewrite this as 2. All right, so 2 times 3 is 6, and then that leaves me, I still have 2 more to go to get to 8. So that's my remainder is 2. So this converted is 2 2/3. Okay, just to show it as division, you're dividing 8 by 3. So if I do a little divide 8 by 3, 3 goes into 8 twice. 3 times 2 is 6, and then I subtract, and I have a remainder of 2. This is the whole number part. This is the remainder part, goes on top of the fraction bar. So there's our conversion. Okay, all right, so I'm going to block off my answer. There we go. All right, and then I have one more example, which is a geometry application. So a little preview of what you'll study next year. The sum of 3 angles in a triangle is always 180 degrees. So that's a truth that you can bring with you into geometry next year, and you'll be able to solve a lot of problems using that property. And the question is asking you to find the missing angle, which you can see is here in the lower right corner. So I'm given 3 angles, and I know that the sum of the angles is 180. So first thing I do is I model it with an equation. I'm going to find the sum of these angles by adding them all up. So I write x plus 94 plus 33. Add those up, they should add up to 180 degrees, so 180. I'm leaving off the degree marks for right here now, but when I write the final answer, I'm going to include degrees because that's my units. All right, so how do I solve this equation? It has an extra step because on the left side we have two numbers. So you should always combine, simplify those together. When they're on the same side, combine them together. So I have x plus, and then these add up to 127 equals 180. I just bring this down. So we're just simplifying the left side and we bring down the right side. All right, now we begin solving. I'm adding 127 to x. So how do I do that? How do I solve for x? I'm going to subtract 127. From both sides. All right, the left side reduces to 0, simplifies to 0, leaving me just x. Bring my equal sign down. Then I subtract these two, and that leaves me with 53. And remembering that this is an angle measure, I want to put the units back, so 53 degrees. And there is my solution. All right, it's time for some practice.